So let's try one more problem. There's a triangle ABC. It is given to me that AB is equal to AC. So these two sides are equal to each other. It is also given to me that E and F are midpoints of AB and AC respectively, and they are connected to B and C. And it is given to me that BF is equal to 4 units, and your question is what is the value of CE going to be. So the information given is very simple. There is a triangle, two sides of the triangle are equal to each other, and the midpoints of the two sides are connected to the opposite vertices. Size of one of these segments is given as 4 units, and you're asked about the other. So once again, obviously by now we should know that we're going to go for congruency, and I see there are two triangles involved. I have AEC, triangle AEC, and triangle AFB. My drawing is not accurate, but you can already see that they're going to be congruent to each other and they can overlap. I want to see if they can or not. It is given to me that AB is equal to AC. This is a midpoint, that means this and this are equal to each other. This is a midpoint, that means this and this are also equal to each other. Moreover, AE is equal to AF. AE is equal to AF. I'm drawing it out separately so that it is more visible to us. We can see the same thing happening here itself. Why is AE is equal to AF? Because AE is half of AB. AB is the same as AC, so AE is half of AC, and AF is also half of AC. So these two are equal to each other, or AE and AF are equal to each other. Moreover, angle A is common to both the triangles. Angle AEC as well as angle AFC, angle A is common. Furthermore, I also know that AB is equal to AC, that means AB is equal to AC. These two sides are also equal to each other. Now very quickly, side angle side are equal to each other. That means these two triangles are also going to be congruent to each other. That means this third side is going to be equal to this third side. That means EC is going to be equal to BF. BF was given as 4, so I can also say that EC is also going to be 4. So more of a problem solving bent, but once again the idea being used is very easy. Spot the congruence and the process will go very smoothly after that. One more result with isosceles triangle. I say this is triangle ABC, and the sides are given as equal. And this time I draw a median. A median is a line which divides the opposite side into two equal parts. That means AO is going to be equal to OC. So this is the information given to us, and the question is what is the value of angle AOC. No other information is given to me. Now once again I see there are two triangles AOB and BOC, and by now I should also know, because the chapter is about congruence, we'll be using the idea of congruence. I see that there are two sides are equal. This side is equal to this side. AO corresponds to OC and AB corresponds to BC. That much is very clear. So there is a side and a side definitely. Do I have the included angle already? Some of you will say, yeah, I know it is an isosceles triangle, so therefore these angles are going to be equal to each other. But let's say I have not derived that result so far, so I don't know about that. This angle I have to find out, and no information is given about this angle either, right? So I have two sides which are equal, but if I look at the third side which is common, that is also equal. That means SSS, three sides are equal. Once again, these two triangles are congruent to each other. That means this angle is equal to this angle is equal to this angle, and this angle is equal to this angle. What that also means is, if these two angles are equal and this is x and this is x, 2x is going to give you 180 using the straight angle, all the angles on a straight line idea. That means this is a that means this is a 90-degree angle, and that means this is also the perpendicular. and because it is dividing it into two equal paths, this is also the perpendicular bisector, this is also the median, and these two angles are equal to each other. That also means this is an angle bisector. Now I can start creating my own theory. Say if this triangle is isosceles triangle, the median, the perpendicular bisector, the altitude, the angle bisector, all of them are represented by the very same line. And once again, this idea, because we've done it so repeatedly over a number of times, once again, this idea proved using the idea of congruence, and you will see this over and over again. And you will see this over and over again in later topics, because when I'm solving problem or trying to present a proof, I will say these two triangles are congruent because of SAS. At that point of time, it should be very, very clear to me both what SAS means and what does congruence of triangle gives me, because as I see, it opens up the whole picture for me very, very easily. So a very, very easy idea and a very, very important tool, because already using this tool we have derived a lot of things about the isosceles triangle. At least we will do more such things, and over again the idea of congruence will be used. So when I am solving future problems and suddenly when I say these two triangles are congruent because of SAS or SSS, the idea should be quite clear to us. And I should also notice that when two triangles become congruent, life for me becomes very, very easy, because jumping from one triangle to the other or equating two triangles to each other becomes very, very easy, opening a lot of doors for me in problem solving.